Good morning, students. Welcome to the lecture series of Introduction to Python. Today we are going to discuss regarding to plotting and visualization in Python. In today's lecture, we will cover plotting of 2D and 3D graphs. We will see the use of matplotlib, pylab and pyplot functions, the basic plots, how to plot the basic plots, setting up and properties of the plots, histograms, bar charts, error bar charts, scatter plots, pie charts, polar plots, logarithmic plots, contour plots, the decoration of plots, subplots, and how to save up plots and how to do a 3D plotting. So let us first start with a basic introduction of what is in plotting. So plotting data is one of the most essential part in numerical computation. In pre-processing, during computation, and in post-processing, the ability of the plot to plot the data on different kinds of graph is essential. Visualization of data is convenient format, allows for better understanding of the process. Visualizing clues generate a lot of information about the process that generate the particular type of data. You can easily look for errors and data simple as well as complex interpretation. A good programming language must incorporate facilities to plot data easily. Plotting two-dimensional data and three-dimensional data is vital for creating a good visualization product. Python has a number of choices regarding this. In this chapter, as I've already mentioned, we will discuss each and everything in this course. The plotting library used in this chapter is matplotlib. Just like any other module, they can be installed using pip on any system, either in Windows or in Ubuntu system. You can, in Anaconda, if you are using Anaconda module for Python code in Windows and Mac OS, you don't require to install this library because it is already been installed. So matplotlib has been created by John Hunter. He rightly stated that matplotlib tries to make easy things easy and hard things possible. In some cases, with just one line of code, you can generate a high utility publication ready graphs of the problem at hand. For Python, GNU plot was used to plot the data passed by a Python script. With matplotlib available, this action has become very flexible. Matplotlib was modeled after the graphic capabilities of MATLAB, which came as a boon of programmers who are already well versed with MATLAB. Some of the major advantages of using matplotlib over other plotting libraries are as follows. It is integrated with latex markup. It is cross-platform and portable. It is open source, so users don't have to worry about license fees. And being a part of Python, it is programmable. Matplotlib stands for Mathematical Plotting Library. It is one of the most important plotting libraries among programmers owing to its simple and intuitive commands, as well as its ability to produce high quality plots that can be saved in a variety of formats. It supports both interactive and non-interactive modes of plotting and can save images in a variety of formats including JPEG, PS, PDF, and PNG. It can utilize a variety of window toolkits like GTK, plus WXVJX, and Qt. The most attractive feature is that it has a variety of plotting styles such as line, scatter, bar charts, as well as histogram and many more. It can also be used interactively with IPython. NumPy is necessary for working with matplotlib, hence it must be installed on the system beforehand you are going to work with matplotlib. Matplotlib depends on creating a set of programs for proper just a minute. Sorry. Matplotlib, as I've already explained, that depends on a set of program for execution. This dependency must be first installed, as I've already informed you. So here in this chapter, as for considering for beginning plotting, we are going to illustrate each and every topic that is possible. Moving to the next section, that is pylab versus pyplot. So Within Matplotlib, PyPlot and PyLab are two of the most discussed modules that is available within it. They almost have the same functionalities and thus cause some confusion among their users. As a result, it is important to differentiate between them at this point. With the package matplotlib, two sub-packages, namely matplotlib.pylab and matplotlib.pyplot, exist. Since plotting can start as a simple exercise and then become a quite complicated one, matplotlib is designed in a hierarchical pattern where, by default, simple functions are implemented in matplotlib.pylab environment. As complexity increases, a more complex environment like matplotlib.pyplot is implemented. A more object-oriented approach is matplotlib.pyplot, where functions like figures, axis, and axes are defined as objects to keep the track of their properties dynamically. For even more complex tasks like mapping graphic user interface GUI, exclusive pyplot has been used. But many of the time its usage can be dropped altogether and an object-oriented approach can be used to fabricate plots. Also, when plots are most non-interactive, the pyplot environment can be used. But when we are going for interactive studies, PyLab is much helpful. So, how do we plot basic form plots in Python? So we'll first explore the working environment offered by matplotlib.pyplot. Functions inside pyplot control a particular feature of the plot, like putting up a tile, mentioning labels, and on labels on x-axis and y-axis, of course, putting mathematical equation in the body of the plot as a desired position, defining tick labels, defining types of markers to a plot, a graph, and so on. PyPlot is stateful. It keeps updating the changes in the state of figure once defined. This makes it easier to modify a graph until the desired level is reached before including the code in the program. The plot function, plot and bracket function, is used for plotting simple 2D graph. It takes number of arguments that fills the data and other features information to plot a graph. It is the simplest form. It can plot a list of numbers. For example, as we are going to check here, as you can see here, the particular I have written this code in Colab. This is a Python code. As I've already mentioned, if you want to work with matplotlib, you have to first of all call a numpy. So I'm going in this particular code, what I'm going to do. In this particular code, it is important to note that libraries, first important note, that numpy and matplotlib.pyplot are used as an aliases np and plt. So numpy is an np and matplot is being used as plt. This is usually preferred by programmers to avoid writing the name of the libraries each time they need to use its function. We will use this convenient in this particular lecture. So I have just given np.arrange10, a range of data from 1 to 10. I am going to plot it. Let's see what the results is. The results can be seen in this particular figure, which will appear now. A plot needs two axes, which are usually termed as x-axis and y. When the plot command is supplied with a single list or array, when the plot command is supplied with a single list or array, it assumes it to be the values for y-axis and automatically generate corresponding x values, taking its cue from the length of the list. We have 10 numbers here as written in the program. Consequently, the x-axis has 10 numbers from 0 to 9. Now, here the range is from 0 to 2. The difference is 2. So 0 to 8 it isn't showing, but it is from 0 to 9. Plot can take both axes as input vectors and to produce a plot, which can be shown in the next code. Here, in the next code, which I am showing this particular code, I have used PyLab instead of my pyplot in the previous example. In the previous where I have used pyplot, here I am going to use PyLab. So the result which you are going to see here can be seen here. The very basic plot could be plotted by just a few lines of code, where you first import relevant libraries, that is line 1 and 2, that is numpy and matplotlib, and then define the x and y axis, and finally use the plot command, which gives the parameter for the x and y axis. This command can be issued one by one at the Python command prompt, or they can be saved as a Python file. Using a text editor, you have to write the code and save it as a particular name dot your name or dot py, and you can see this. The axes are defined as a numpy array. They can be generated by all the methods available, including creating them by hand using the formula like in code which I have shown in this particular code, like y is equal to x squared. Okay, this is the another method of importing. You can also import using this particular command. This is one of the method to import a function, or you can also import using this particular command from matplotlib import panel. So there are two methods which I have shown in this particular different codes. Beside using a data file, what we are talking is about array x and y, how x and y can be generated. The axes which are defined by numpy array can be generated by different methods. The methods available including creating them by hand using a formula as I have shown here, which I have already mentioned, and using a data file, taking data live from remote local server using internet online, and so on. Subsequently, in later, if possible, we will discuss, we will deal with file input output facility, but here we are only going to concentrate on simple function. Okay, it is worth mentioning the role of seemingly simple but powerful function show, show. A simple search at the command prompt, this particular line, show. A simple search in the command prompt, if you write matplotlib.pyplot.show, you will get it purpose. It displays figures on a computer terminal having graphics capability, which most modern computers do. In the non-attractive mode, in an IPython console, it first displays all the figures and blocks the console until the figures have been closed. Conversely, in an interactive mode, it does not block the console. Both the modes have their own merits. The interactive mode is used for checking the change in feature. Okay, the interactive mode is used for checking the change in feature, and the non-interactive mode is used when the focus is more upon the code, the generation upon code generation that produces the graph. Usually programmers work with the interactive mode and optimize a view plot, and then work with the non-interactive mode, taking the same settings that were generated during experiments with the interactive mode. I hope it is clear what is interactive mode and what is non-interactive mode. Well, I think I have forgotten to change the slide. No, don't worry, but I am going to share this video with you in the group, so it will be helpful to you. So let's move to further example that we are going to take here. Here I am going to show you how to plot basic more than one plot on the same axis. This particular next example which I want to show you is important from that point of view. It is same. So it is possible to plot more than one graph on the same axis using Python, using programming. In this particular code, as you are seeing, what I'm going to do is here there are two y-axis, y1 and y2. Y is the square of x and y2 is x raised to power of 2.2. Okay, we are going to check what would the output in this plot of this two plot command. Just as an example, you can do more than 2 or 3 functions. Okay, that is possible. Now moving further, let us talk about the various features of a plot. The variety of features that exist for a graph. A variety of features. We are going to look over some of the features. Okay. The first feature of a graph is title. As you can see, the title gives a short introduction, a very short introduction of the current axis, purpose of the graph. That is the title object sets the title of the current axis, position about the axis, and at the corner in the center. It takes the string as input. The next thing is labels for axis. Labels marks the purpose of the graph axis. X label and Y label are the two functions that is used. The objects set the label of X and Y axis respectively by default. The text string is used as an input, is positioned above the axis in the center. The third important thing is tick. Ticks on the axis shows the division, the data points on an axis. It helps in judging the information about data points on the graph. Similarly, to label, there are X ticks and Y ticks, a set of ticking, frequency and location. For example, X tick arrange 5 A B C D E, and it will give you a 5 ticks named A B C D E on the. You can lose line space and log space for the same. Another important feature is mark. So markers are the symbol drawn at each data point. Each data point by means the marker, the size and the type of mark can be differentiated. It is similar to the points that you can mark on the curve. In a plot function, every pair X and Y, there is an optional third argument as a form of string that indicates the color and line type of the plot. A list of marker can be available from matplotlib.org platform. You can go through that particular line. The third, another important parameter is line width. It defines the width of the marker if it is equal to n, where n can be a set of integers setting the marker size at a particular dimension or desired dimension. Then comes line style. Line style defines the style of line. Once again, I have forgotten to change. Line style defines the style of lines that connected the marker. Okay, they can be a set of when data point don't need to be connected. For example, test line or star line or point line. Okay. Similarly, one important feature is color. It shows the color of marker. It can be used for distinguishing data points belonging to more different type data set. But this method cannot be used where data needs to be published in black and white color scheme. Okay. So these are some of the marker style which I would like to show you. As you can see, there are point, pixel, circle, triangles, variety of markers that is available. In the similar manner, let's move further. There is one more feature called grid. Okay, so grid commands can be turned off on the graph using the following sentence. That is, grid is equal to true or grid or false. The grid lines which you can see on it. Then comes legend, another useful feature that is used for differentiate different type of data types or data points or multiple graph in this figure, as I was shown earlier. You can you go for its illustrated usage over matplotlib.org platform. By default, legend takes the input as a string provided within the plot function under the flag label equal to the flag label. This location is set on the top right corner by default. It can be changed as well required by using the LOC argument. These are some of the points which I would like to share with you. These are various features of a plot. Not limited to, it can be expanded. There are many more, but these are the minimum features that can be important. These are the line and color style which I have already explained to you. The color abbreviation and the name. Similarly, style abbreviation and style name. Now setting up the properties. So how you set up these properties? We know these are the major properties of plotting. But how are you going to plot? How are you going to set these properties up? So in this particular example, I have written a code here to understand how to set these properties. As you can see here in this code, which I'm going to show you. So here I have imported pylab as PL and numpy as NP. Okay. The sequence doesn't matter because it is Python. It is easily. I have created a figure. As you can see here, a variety of options are available in 2D styles for setting line properties of 2D plot. uh, this particular code will show you how to set a feature of each and every code. Okay, now here we have created a size means a figure of size 9 by 7 inches, 100 dots per inch. Okay, secondly, this particular line plot subplot will help you to plot a subplot. Here it is a 1 by 1 grid format, so there is no need to worry. It could be 1 by 2, 2 by 1 in the 2 cross 2 matrix. Now we used to plot in this particular example sin x and sin 2x. Okay, sin theta and sin 2 theta by simple understanding. So first we'll define x-axis using a simple line space, that is linear space, which we have already explained before. And here 2 pi minus 2 pi to 2 pi is the range, and I have written the point 10,000. Means this particular range has been divided by 10,000 points. Okay, where the last point is also included using this endpoint rule. I hope you remember this all thing in this previous steps. Now similarly, s and h2, that is np dot sin x and np dot sin 2x. So this plot sin x will a blue continuous line of width 1 pixel is labeled as sin x, which I have already mentioned here. The line width size will be 1 and line style is dash. So label will be sin, and the dollar sign is 20 here, which will be explained later. Now similarly, we have pi plot h2. We have to plot sin 2x also, and I mentioned the sin 2x in between the dollar line, which just to explore that it is an equation. Now I have to set the limit of x-axis. The previous example we have already given the equation of x, what is x actually, but now we have to set the limit to x-axis. So it is from minus np means minus 2 pi to 2.5 plus 2.5 pi. Similarly, the text has to be spaced using np line space. It is minus 2.5 to plus 2.5, and it has been divided into 9 different. Here I am not going to divide it into 10,000 points, just to mention it is a graph. It is showing the x-axis of the graph. So 9 points is enough. You can change the number as per your wish, and endpoint will be considered. Similarly, a wide limit from plus 1.2 to minus 1.2. Here the negative sign will come first, so negative 1 is. And similarly, I have to set the y-text. Okay, now I have to set the title using pl.title and sin x and sin 2x wave, which I have already mentioned here. Similarly, y label and x label has been set. X label will be x, y label will be sin x and sin 2x value, and grid has been shown. So legend, of course, legend, to show a legend one corner from differentiating two curves, you can write legend, and if not, you can just exclude this particular line. Now let us check whether it is working or not. Okay, first of all, if you can see, just to here, the legend has been there. Sin x and sin 2x is like that as x label. The bits are as per our and similarly here it has been divided by 9 different subparts. Great. This are and the sign has been done. So this is the simplest example of setting up a particular graph. A simple example. You can set up your graph using different properties. So the setup and getup objects allow us to use set and get properties of the object. They work well with matplotlib objects, and for the object plot or setup can be used to set the properties. We can actually don't need to get in XC detail of this particular thing. So whenever you're going to plot a function or you're going to plot for any numerical method or physics problem, just make sure that these are the points which you have to keep in mind. These are the points. Okay? You can practice it more and you can move further. Okay, now let us move further to our next slide, which is histogram. So this is the first plot. Now we are going to talk about different type of plot that is available to us. Just remove this plot. So I know you all are aware about histogram, but just for the clarity purpose, let us go in detail about this. The histogram use vertical bar to plot events occurring with a particular range in frequency, which we are calling it bits. They can be simply plotted using HIST function. Okay, a simple example of histogram is shown in this particular code, and you can see here, if you can get this code here, I think it is visible. Okay, here simple random number has been generated, and I am going to plot histogram of A. So what will be the output? This is a random number, so the graph which has been shown in this particular screen, the slide, may vary. Okay, so this is just a random number. It will change every time when I run this code. It will vary because this is a random number of generation. If it is a particular simple statement, the data bit, then you can actually generate it. Similarly, I am this is another code of the same histogram type, and here it shows that total number of bins has to be 25. So bins number has been divided between 0 to 1 has been divided into 25 number of bins. This is a particular thing just to explain. It is important to note that since we use random number, the each function different plot in each and every of your system. Okay, in the similar manner, here the next example which I have shown you, that is here, shows the bins to be divided into 25. It could be divided into 50, and the frequency can be changed, and you can just get the bin output of each number. Okay, so this sets the number of pins, how many pins you want, and you can just vary it and you can check it by yourself. Okay, moving further to our next slide, that is bar charts. So bar charts are similar to histogram, but still they are different, as you all know. Okay, it is one of the simplest plot that employs rectangular bars horizontally or vertically, where the height of the rectangle is proportional to the data value. This kind of graph is called a bar chart. A bar graph are generated by using bar function, which can take two input defining x and y axis, as opposed to the histogram function which only take one input. Okay, this is the major difference between bar chart and histogram. Means bar function and histogram function. Simple code has been explained here, which I am going to show you in this Google Colab platform. Similarly, bar H is been used for plotting horizontal bars. That has to be keep in mind, because there are two types of bar charts, one is horizontal and one is vertical. Okay. Now let us see what let us see this using a simple example. How does this bar chart plot work, bar function work? So here it is, as you are going to see the matplotlib. I used this function as simple it is required. I use np array for x and y axis to generate an axis from 1 to 9, and that last one is 0, and similarly similar type of, there are 10 inputs and 10 in x and y both. I am going to plot a bar chart x and y. The title will be given using and labels as well, and the plot will be shown here. As you can see, this is the vertical manner. So when x is equal to 0, it is the value has been changing as per requirement, and at the end it will be 0, 7 and 0. So I think it is clear to you. Now this is a vertical bar chart. If I want to plot it into a horizontal, so I will use bar H instead of bar. All the code remains same. The display changes, the display part changes, and you can see the code here. It varies, it changes itself. Okay. I hope it is possible. It is understandable to you. Okay. Now let's move further to the next portion, that is error plotting. Error bar chart. How to generate an error bar chart. So some of you are familiar with this error bar chart, and some of you are not. For those who are not, let me explain it. Error bar chart is one of the important part of any programming language. It is an important part of any scientific study actually. All the experimental scientific work involves error, and it is important to plot error along with the data for many reasons. Error must be plotted so that you can judge data quality and understand the regions of data where error is huge or minuscule, minor. In matplotlib, the error bar functions enable you to create such graph called error bar chart. The error bar function. The representative of the distribution of data is done by plotting a simple data point, single data point, commonly the mean value of the data set, and an error bar to represent the overall distribution of the data has been shown. To accomplish this, the code plot simple code has been shown in not Matplotlib, but Google Colab platform, which plot an error bar. Okay, it is just a simple code for demonstration purpose, and you can see that you will see that we have defined an array for its purpose. For just let us go to the platform. Yeah, as you can see here, arrays for the x-axis has been defined, and similarly for the y-axis has been defined, and here we have used the formula y is equal to x square. Error is stored in the third array saved with the variable name err. This variable name are passed as an argument to the error function, and hence it takes three variables in sequence x, y, and err. Now the output of the file will be shown here. Now let us run the code first. I hope you understand this. And this thing. Now I have written this randomly. Initially it is 0, then comes 0.1, 0.1, then 0.2, 0.1, 0.5, 0.9. So this is error which is available to us as per our study when you do some experiment. Okay. It may vary. It is used as an input. Similarly, color has been used here. Is used to color the color bar. So just as you can the value of YERR, that is keyword, you can set the XERR. So YERR is equal to here. You can also set XERR, that is on x-axis and y-axis respectively. So that is error bars for x and y. Okay. Now here we have seen that no asymmetrical. Sorry, with bar charts with symmetrical error. Okay. Now, what are the bar charts with asymmetrical error? That are asymmetric error. That is, I think you know what is symmetric and what is asymmetric. Here, bar charts are symmetrical. That is only positive, and negative values are equal. What if they are not equal? So we have to incorporate two different values, two different arrays for error definition. So here I have shown you in this particular code, that is in this particular code, as you can see here, the code is from 0 to 4 it generates data point with step size of 0.2, and similarly y is equal to x square, and you can also use this particular code. I have not used. Now here I have gone through the error of positive and negative. Just for understanding purpose I have written err underscore positive. You can also use some other name. Now plot error bar function xy. YERR will be err positive, err negative. Both must see that the positive comes first, then comes the negative. The rest is same as in the previous code. Now let's see what is the output, and you can see how easily it has been changed. There is -2 in the positive negative direction, +2 in the negative positive direction. I hope it is understandable. If I'm not, just if you have placed it in a wrong manner, then the thing will change. You can change this positive to negative and negative to positive. You can see what is the mistake done here. Yes, there is a simple mistake here in this particular line. Just check it and let me know. Okay, this is a simple way of plotting an asymmetric error bar, a simple way, and previously we have plotted a symmetric error bar. Asymmetric and symmetrical error bar. I hope it is understandable to you. So next we move to scatter plot. I hope you are know what a scatter plot is. So scatter plots are, as you can see in this figure, they are scattered values, scattered manner of plotting the data, and it is quite easier to understand what is scatter plot.